Hey Jason, here's another presentation, but this one is about the ELISA test. Here I will demonstrate the ELISA test. The well is coated with the antigen of interest, which is our viral antigen. Substance A is then added to the antigen, then incubated for about 15 minutes, which will allow our primary antibodies to attach themselves to the antigen. And then after, the substance is washed away along with the unbound antibodies. So for this one, I'm going to attach my primary antibodies. This right here, my primary antibodies are all in the solution. When these are washed away, only the ones that will stay are the ones that are bound. So in this case, there are only 2 of my antibodies, my primary antibodies, that will stay with my antigen. Next, substance B will be added to the well and then incubated for about 15 minutes once again. And this will allow secondary antibodies to attach to the bound primary antibodies. Any unbound secondary antibodies are washed away. So now I'm going to attach my secondary antibodies. It's the same case as the first one. So my secondary antibodies will attach to my primary, and since I only have 2 primary antibodies attached, I will only have 2 of my secondary attached. So when the PBS buffer is added, or my wash away solution, only 2 of my antibodies will stay. In the last step, the substrate detection is added and then incubated for about 5 minutes. This will allow substrates to attach to the secondary antibodies because secondary antibodies are enzymatic. And when they are attached, it will produce a color to be analyzed. So in this case right here, enzymes will attach to my secondary antibodies because they are enzymatic at the top right here. And when enzymes are bound to my secondary antibodies, this will produce a color in which will be analyzed for how much antibodies you have. Now I would like to demonstrate a positive control, negative control, and patient samples 1 and 2. A positive control is a sample that is known to work effectively. And to demonstrate, the viral antigens will be placed into the well. And my substance A, which contains my primary antibodies, will be placed and attached to the antigen. In this case, all the primary antibodies will attach to my antigen because they are known to attach. And so, in this case, when I add the PBS buffer, these primary antibodies will not be washed away with the PBS buffer. So when substance B is added, and which is the secondary antibodies, they will bind to my primary antibodies. So in reality, I will have each secondary antibody connecting to my primary. And since these are all bound, they will not be washed away with the PBS buffer. So when the substrate solution is added, the substrates will bind to the secondary antibodies, which will also cause a color reaction. In this case, what the color reaction should be a dark color that shows a really good number of antibodies. For my next demonstration, I would like to perform a negative control. A negative control is a sample known that it will not work effectively. So the viral antigens that are placed into the well once again are viral antigens. Substance B will be added this time. Substance B, which contains our secondary antibodies. Go ahead and try to attach them. The question is, will these two secondary antibodies bind to the antigen? The answer is no, because the secondary antibodies can only bind to the primary antibodies, and there are no primary antibodies present. So these will wash away easily with our PBS buffer. Lastly, I would like to describe the patient samples. In sample 1, substance A contains the fork-ended and the flat-ended IgG and IgM antibodies. So I will go ahead and attach all my fork-ended and flat-ended antibodies. So when the PBS buffer is added, only the fork-ended antibodies were bound to the antigen. So in this case, when the PBS buffer was added, my flat-ended antibodies were washed away. And so that left me with all my fork-ended antibodies. So when I add substance B, which contains anti-human secondary antibodies, will these attach to my primary antibodies? And these actually do combine with the primary antibodies because there are primary antibodies present. Now, the question is this person immune to the coronavirus? The answer is no, because any secondary antibody will bind to an attached primary antibody. So this actually makes them more vulnerable to the coronavirus. And lastly, I'd like to demonstrate sample 2. Substance A contains the flat-ended IgG antibodies. So I'll go ahead and attach my flat-ended primary antibodies. And these were actually washed away when the PBS buffer was added. And the answer is why? Because this means only the fork-ended antibodies will be able to attach, or any other antibody will be able to attach to the viral antigen, but the flat-ended. So these were actually washed away, leaving this vulnerable. So substance B is then added, which also contains anti-human secondary antibodies as well. And the question is here, will these bind to the antigen? Or will these remain bound after washing? The answer is no, because there isn't a primary antibody to bind with once again. So these will wash away with PBS buffer. The question is this person immune to the coronavirus? The answer is no. This actually makes them more vulnerable because they don't have any antibodies present. And another question is this person infected? It is most likely this person is infected because none of their antibodies are fighting against the viral antigen right now.